Hi everyone, welcome to Vishwablooms. So in this video, we'll be looking at optics, class 8, concept 2 packages, physics, techno. So let's quickly start with the clarity achiever question number 1. The magnification of a plane mirror is. So in the explanatory video, I have already told you what is the magnification of the plane mirror. So if you haven't watched that video will be available in the playlist. So I hope you are all able to see the playlist name below the title, so you can click on that and watch the concept to explanation in order to find the answers for all the questions in this video. So the magnification of the plane mirror is always +1, because see, now why is it +1? Because magnification is nothing but the image size by object size, right? So image size and object size both are going to be the same in the plane mirror, so both will get cancelled and answer is +1. Understood? Suppose now if this is a plane mirror and you are the object here, now image size, suppose it was 5 meter, you are 5 meter, suppose, okay, sorry, 5 meter, let it be 5 feet, not 5 meter, 5 feet. And object size also in the mirror you will find yourself to be the same, so object size also is going to be 5 feet. So 5 by 5 is nothing but 1 only, right? So that's what +1 is the answer, which is option A. So this is also discussed in the explanatory video, no need to worry. So yeah, now second question of the clarity achiever, statement A. If our eye lies in the field of view, then only we can see the image of the object. Now field of view we have discussed, right? So in that, so we had a mirror, and here when we had the object here, so where will we get the image? We'll get the image here, right? So that's what it will get reversed. So these are the rays which we cannot see, virtual ones, so they will get reflected back, right? It's like this, sorry, yeah. So when you are there only in the field of view, now maybe this is the maximum field of view for this, in this portion only you will be, if your eye is there in this portion only, then only you will be able to see the image, or else you will not be able to see the image. So that's what a line is also there in the book. If our eye lies in the field of view, then only we can able to see the image of the object, otherwise we cannot even see it. Now suppose if your eye is here, maybe this is eye, okay, can you able to see the image? No, because the field of view is only till here, and the eye, whichever it is here, there, no, it cannot see. So option A, sorry, statement A is correct only, because they have given that it can only see if it is in the field of view, correct. Now statement B, in case of plane mirrors, object distance is equal to the image distance. Obviously this we have been studying since the first concept, right? That's this was the law of reflection also, that when there is a plane mirror here, now suppose this man is 2 meter in height, the image also is going to be the same height, 2 meter. So in case of plane mirrors, object height is always equal to the image height, and that is a true statement. So with this makes us to bring with option A. So we can choose the option A, correct. So next we'll see the third question. The focal length of the plane mirror is. Now focal length, as you all know, there is focal length generally for a plane mirror, so it is infinity. Okay, so infinity is the focal length for the plane mirrors. Normally generally for the curved mirrors, right, we will have the focal lengths, because we will have something called radius of curvature. That is very much important for determining the focal length, okay, because r is equal to 2f1 formula will be there, and now you will not have this, don't worry, you will have it in the upcoming classes or in the upcoming concepts, so don't need to worry, I'll explain you there, don't worry, just I'm telling you. So focal length will be there in your higher standards, not in this concept, that's it, okay, it will be there in spherical mirrors, not here, so you can just take it as infinity, option C. Now for the fourth question, a beam of light incident on the plane mirror forms a real image. So there is one beam of light which is incidenting on the plane mirror here. Okay, plane mirror is there, so it got incidented on that. It's okay, and it forms a real image. It didn't form a virtual image but a real image. So now obviously one thing you have to keep in mind, when the image is real, we have image is real, right? So obviously what about the object? Think of it. You're right. So if the image is real, object is virtual. So object is something virtual, then only image can be real, because you have to recollect the concept too, or else see that video. Okay, in that I have explained very much detailedly why it is a virtual image. When you have a real image, there is a virtual object, and when you have a virtual image, you have a real object. Okay, so now if you stand in front of your mirror, which kind of image are you able to see? You will see a virtual image because you are a real object, right? So that is what. Now, what is the question? Let's see. The incident beam is, so the incident beam, what kind of beam it is, we have to tell. Whether it is parallel. So you all know what is parallel, right? Sorry, I'm sorry. So parallel beams will be like this. Okay. So here I'll just change that. I'll draw this. So parallel beams are something like this. Parallel beams. And if you ask me about convergent, see what happens is here the various rays come together and go and meet at one point. That is convergent. So here various rays are there, right? So that various rays, they are meeting at one point like this. Many rays are going and meeting at one point. So that is only convergent. Now what about divergent? So divergent is nothing but from one point many rays will be like passing, okay, from one point. That is divergent. And the next one is perpendicular. So perpendicular, generally in mathematics it is like this, right? So that kind of array, so that kind of a beam. So here in this case the answer would be B, that is it is a convergent beam. So the incident beam whatever was there, no, it is a convergent one. Okay, convergent. So option is B. I hope it is clear to you all. So next, let me go to the silver packages in the ASA. So statement 1. First question, statement A. Radius of curvature of the plane mirror is infinity. Just now we have marked it in the third question, right? So I told you focal length question was there. Focal length of a plane mirror they asked. I told you it is infinity. Now they are asking us what is the radius of curvature of plane mirror. See, plane mirrors are generally flat and straight, right? They are actually not curved, so they do not have any radius of curvature. So we can say that the radius of curvature for any plane mirror is obviously infinity. Okay, so and that statement is true. Okay, so just you mark it as true. And looking at the statement B, image formed by a plane mirror is erect and the same size of an object. So here image is formed by a plane mirror. So we have seen the characteristics, right? So in that, what we have learned, so we have already learned about this. See, now I am taking one plane mirror here. Okay, so plane mirror is there and now object is there. So now whatever the image you see, you see yourselves, and what is it? It is erect. That means it is straight, this direction only. Erect means up same direction. Now you are standing in this way, it will show you this way itself. That is erect. Obviously it's true. And it is same size of an object. Yeah, I told you, right? If you're 2 meters, here also 2 meters. You have seen multiple times this one. So statement B is also true. I hope you understood this. So which is the option? Option A. So I am moving forward to the second question. Statement A. The field of view is the region between extreme reflected rays. Now just now we had one question on field of view, right? So if I am taking this to be a plane mirror, and I'm considering this as an object O, and from this I'm passing few rays. So this will get reflected this way, and if I take rays like this, sorry, this way, so in this way maximum rays will be reflected back, right? So now what happens? What is the statement which is given? Field of view is region between extreme reflected rays. Yeah, so this is only field of view, right? Between the extreme reflected rays, what are the last point of reflection? Those rays, between them only we will be having field of view. That is only field of view, right? So yes, so that is a true statement. So let me erase all this because I need to explain statement B also. Field of view, yeah. So it's a true statement. You have seen about field of view here. Now statement to be field of view. So it was a field of view depends on the location of the object in front of the mirror. So now this is the, suppose this is the location of object. Okay. Now this are incidented and these are the reflected rays. Now maybe these are the extreme reflected rays. Field of view will depend on the location of the object in front of the mirror. Yes. Now, if the object is here, the extreme levels are here. The field of view is still here. Now, if that object was somewhere here, then its reflected ray, its maximum reflected rays maybe would be only till here, right? But this side it would be more. So, obviously, keeping that in mind, this statement is a true statement. Understood? So both are true statements and option is A. Mark it. Now third question is something in which you have to do calculations. So what we have to calculate here? Let's see. Calculate the shortest height of mirror in which a man can see his full length. Now, for explaining this question, let me take one new slide. Okay. So first, there is a man, okay? He is height man. Let his height be h. Okay. Let the height of the man be h. Now we have to calculate the shortest length of mirror. We have to calculate this height of the mirror. Let it be L. Length of the mirror, let it be L. We have to find the shortest mirror, shortest length of the mirror. Okay. Not a larger one. If it was same height of him, yeah, he would have seen himself. If it is have been larger than him also, he would have able to see himself completely, right? But they are asking us to find out the shortest one, not the largest one. Largest one is infinity. Anyways, shortest one we have to find. Okay, so how do we find this? That is a question. Now this man is heighter and this mirror is smaller. So what are its maximum extent this can show? Let me draw straight first, okay? To the mirror, this much part it can show parallelly. Now let us draw how much it has to show. See, this much it has to show, this man. Correct. Now, yeah, so these two look like some right angle triangles, right? Yeah. So now if we think here we have suppose let's incident a ray from this part. If we incident from here, obviously this is going to be the reflected ray. Now maybe this is a equal half, let us assume. From this again I am incidenting towards this part and this is the incident ray, this is the reflected ray. Right, now all this 4 will be equal, remember, because I have taken from the equal part, and incident rays and reflected rays always will be equal, remember that, right? Because I am taking from the same point. And here it is parallel, right? This man will be straight. I'll show the diagram which was already there, right? So that's what. So remember that these 4 lines are equal in length. I'll show you neatly in the diagram, no need to worry. This is just for explanation, okay? So now what we have to find is, we have to calculate the L, okay? Now let me erase all this and we'll go to the previous slide. So I've drawn the perfect image for this. And here everything I showed you. So this one, this one, this one, this one, they are of equal length. Remember that, because it's the point which we have drawn, the incident rays and reflected rays both will be equal. So remember that and keep that in mind. So yeah, now you see something new here which I have not told you, that is m dash d and mb. So these two are, what are they? Perpendiculars. I have drawn perpendiculars from these end points of the mirror to the man's side. Okay, so they are the perpendiculars. Just remember that. This diagram is very much important. You can actually memorize it. Sorry, you can make a note of. So first, I told you. So we have named the mirror as m dash. Let the name of the mirror be m and m dash, and that is the length L. Okay. Now, so m dash is equal to L, and AB is height. That is the height of the man. I have already told you. So keep that in mind. Now, I have to show that this is the shortest one. I have to find out the measure of this. No. So let me try in different ways. Okay. So first, what I am going to do is, I am going to consider these two triangles. I am going to take them as triangles. Okay. Yeah. So let me take those triangles. That is A m dash D and C m dash D. Okay. Now in these two triangles, okay, what I am going to show is that these two are congruent. Maybe you all know what is congruency. So what is congruency? Congruency is nothing but showing that two triangles or two shapes are a ditto of each other. They are the same. They are same. Their measures, their angles are equal. Their angles and their lengths, we have to show that they are equal. This way. Okay. That is only congruency. So we have to prove that that these two triangles are same of each other. They are congruent. Okay. We have to show that. Okay. So let me show that. For congruency, we have actually totally four rules. Okay, you will be studying in actually 9th standard congruency rules. In your mathematics, you will be learning triangles. Okay, so what will be there is, there are four rules to show that. First and foremost is SSS rule. SS is congruency rule. Second one is SAS congruency rule. Third one is ASA congruency rule. And fourth one is RHS congruency rule. You learn about this detailing in 9th class, and when you come to 9th class, you will be able to understand this problem very clearly. But we do not have that time. So I'll try to give a brief explanation for this. Okay. Now I'll just give you some examples so that understand this, because I have to explain the problem. Right. So let us assume these two triangles to be, let there be two triangles like this, ABC, PQR. Now I have to prove that these two are congruent, but they will give you some information. Okay, maybe like this angle B is equal to angle Q is 60. At least they'll give you some hints. Okay, if you have three measures at least of both equal, any measures, it can be either angle or it can be either length. Okay, if any three, that means it can be one angle or two lengths, or two lengths and one angle, or three lengths also is no problem. That is only SSS, SAS and ASA. That is side, 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 side angle, side, angle, side, angle, and RHS I'll tell you. So that is what, okay, if you have any at least three measures known and they are equal, you can simply tell that they are congruent. Congruency symbol is this. Okay,
so this question is like the values won't be given directly, but I'll give you an example which is going to be completely brief.
equal to PQ is equal to 6 centimeter, and BC is equal to QR is equal to 7 centimeter. Angle ABC is equal to angle PQR is equal to 60 degree. So therefore, by SAS congruency rule, triangle ABC is congruent to triangle PQ. So that is how you will show actually. And after knowing congruency, you should know something called CPCT. CPCT is nothing but corresponding, I'll write it away, corresponding parts of congruent triangles. So that is what is CPCT. Okay. So corresponding parts of congruent triangles are equal. That means if previously I showed you, right, this triangle and this triangle, this is 6 centimeter, 7 centimeter, and angle is 60. Now if we know that, we can say that this side and this side also will be equal. This angle and this angle also will be equal. This angle and this angle also will be equal. Directly we can say that statements. Okay. So by how we will say that? By using the CPCT. So that's what. Okay. And I can't even elaborately explain to you because it will take literally a lot of time for me to explain this concept clearly. So I can't take that time. Now RHS is something which we are going to use here actually. Okay, so we will use RHS. So RHS is nothing but when you have two triangle, when he has given that right angles are there, hypotenuse is also equal, and any of the side is equal, then you can show that these two triangles are congruent by the congruency rule called RHS. Okay, one right angle, one hypotenuse, and any side. Clear? That's what is RHS. So now I hope this congruency rules also I've explained you, but it might not be so clear to you, and it's actually not much necessary for you. So it's okay, let it be. Now here M dash D, both it is common for both the triangles, right? So just put it M dash D is equal to M dash D. It's common for both triangles. Just write the reason common, okay, in brackets you have to write, but I don't have space. No worries. Next, see, I told you these four are equal, right? So you will only use AM dash is equal to CM dash. Why? Construction, you just write it if you want to write the reason, construction. Next, we have right angles here. We have told you perpendiculars, right? That means right angles only, no? So that's what. Angle ADM dash is equal to angle CDM dash. So by this, these two triangles are congruent. And now what I want to show, why I proved congruent? I want to show that AD is equal to CD. That's it. So now I can write AD is equal to CD by CPCT. Okay. So just write it if you want. It's actually now, because as you don't know, just write this one directly. No need to write all this elaborate one. Just write this, that these two are congruent in. Now those two triangles I told they were equal, right? I mean congruent, right? Now similarly here in the down below part also we have two triangles, something of that sort, right? Two right angle triangles we have here also. So you just write it as similarly these two triangles are also congruent. Just write it. Okay, triangle names you just write it, and from that we will say CE is equal to EB. So triangle name, if you want me to write, I'll write it CME. Just put triangle logo here, and is congruent to triangle BME. Similar way how we did like that. So just write similarly. Now this we have shown by CPCT. Okay. Now those two CPCT statements I write separately and I'll solve it. Now first statement which I told was AD is equal to CD, which we have shown using the congruency by CPCT. And next statement I told that CA is equal to EB by CPCT I have shown. Now let this be equal to X and let this be equal to Y. Okay, we are just naming them. Now here X, X, Y and Y. Okay. Now what is the height of the person if I ask you to write in terms of X and Y? How you will write? Obviously 2x plus 2y. You will add up everything, right, in order to say the height of the person. So what you will write? X plus y plus y. So h is nothing but 2x plus 2y, right? Now h is equal to, I'll take 2 common, 2 into x plus y. Now here length of the mirror, once you see, this is right. So we have drawn perpendiculars like that only. length of the mirror is nothing but x plus 5. Am I correct or wrong? Correct. Right, so h is equal to 2l. Correct. Now we are supposed to find l, right? We don't know l. So now we have something related to l. So l is equal to, what is l equal to? L is equal to h by 2. Now we got something like this and options are something like that. So how do you get it? So first option, half the height of the man. Now h by 2 is nothing but half the height of the man. Yeah, that's only the option. So it is option A. So the shortest length of mirror can be half the height of the man. Understood? So that's what. Yeah, I know it was very lengthy. So now fourth question, passage type of question we have. Okay, so if a reflection of light is observed in two cases, so they are plane mirrors and curved mirrors. I've already explained this. The basic law of reflection are same for plane and curve. The point of intersection of incident rays is called as the object, and point of intersection of the corresponding reflected ray is called as its image. So all these points I've detailedly discussed in the concept explanatory video, so you can check that. Okay. Now, first question, the angle of incidence is equal to angle of reflection. It is called as, obviously it's a law from reflection, right? So it's a law of reflection, option B. Okay. The second one, the point of intersection of incident rays are called as, just now in the sentence we had, the point of intersection of incident rays is object. So option is C, objects. Object or image can be, it can be real object, real image, it can be virtual object, virtual image. So obviously I would say both A and B, so that is C. It can be either of them. Okay, not both of them, either of them. If it is a real object, virtual image, virtual object, real image. That's it. That is clear. Next, fourth one, we have actually options. Let's mark the correct options because it's multiple type of a question, multiple answer. First one we have A, B, C, D. So let's just put it on. So first A statement, image of a virtual object is virtual. See, I told you, real object is there, virtual image. Virtual object is there, real image. But both can't be virtual, both can't be real. Statement A is wrong, obviously. Next B, if the incident rays are converging, we have a real image. Yeah, we have already seen this in the clarity achievers, that if the incident rays are converging, then we'll have a real object. See, if the reflected rays are converging, then we have a real image. Correct. So if you have incident rays as converging, then real object. If you have reflected rays, see first incident rays, if they are converging, then real object. If reflected rays are converging, then real image. Understood? That only you have to understand. See, D option will see, if the image is virtual, the corresponding object is also virtual. I told you, right? If the image is virtual, then the object has to be real. So this is also false statement. So only option B and option C are correct. Okay, so let's move on to the next fifth question. We have a diagram here. An object is placed in front of a plane mirror of length L. L is the length of the plane mirror, M dash. Here M dash is there. It's actually not seen. Okay, so just I will mark it M dash. You can see now, right? Yeah. So, yeah, sorry. Now, at a distance D of its bisector line, that means this is the bisector line and this is a distance D, it seems. Okay, he has given that. An observer is at a perpendicular distance of 2D. That means from here to here. What is the distance? 2D. This is D, this is 2D. Okay, here it's already mentioned. So you can have a glance over that. Next point what we have is, if the observer is walking parallel to the mirror. Okay. Now here, this is the observer, right? So if this observer is walking parallel to the mirror this way, if he is walking, okay. Let's see the questions now. So I'll erase this. Okay, yeah. First I will do the fourth question. then I'll do all other. Okay, because fourth one is something in where you have some numerical part. That means you have to solve. Okay, so we have to solve, right? So let me solve that first, because if that is done, I can show the remaining questions even easier. Fourth question, up to what maximum possible distance the observer can observe the image of an object. Now this is an object. Now up to what maximum distance this observer can observe the image. This is here image will be there, right? Real object means virtual image. This side, right side, you will have the image. So up to how much possible distance he can observe the image. That means if he keeps on coming here, he can't see, at some extent. So up to which extent he's asked. So let's find out. Okay, so for that, but before that, see this measures are also given. So see that. Okay, so this ZQ and PX are equal to the height of the mirror M dash, and these are half of it. Okay, halves of it. Okay, so yeah, that is something which you have to keep in mind, because that is important, because we're going to use that now for the fourth question. Okay, yeah. So now I told you that up to what extent if he comes, he can see the image. See, now this total height first you find out. Okay, now first I'll tell you that in the next page. No, or it's here. L plus L by 2 plus L by 2 plus L will be the height of the person first. Let's find the height. His height first we will find. So 2L plus L plus L plus 2L, or else I'll do in the next slide. Maybe you're not able to see. Sorry, I'll erase it here and I'll do it in the next slide. First, what I'm doing, I'm going to find the height of the person. L by 2 plus L by 2 plus L. So I'm finding the LCM 2L plus L plus 2L by 2. So what it is going to be, plus 2L, 4L, 5L, 6L. 6L by 2, that is nothing but 3L. So up to what maximum extent he can see, that is 3L. That's it. Height is 3L. You can up to that maximum extent only he can see. Okay, so that is option B. Fourth solution is option, sorry, here L is there, right? B. Clear? So fourth one is done, right? And it's option B. Now first and third questions, they actually mean the same, but questions are different. Yeah, you'll see questions are different. How do they mean the same? But I'll explain you so that you'll understand, because there is going to be only one single solution for it. Okay, and then we'll solve the second one at the last. Okay, now in the second question, what he has written is, see, first let's see the question. If the object is moved closer to the mirror, then what is the field of view? So the question is, see, now this is the mirror. Object was initially here and object is moved towards the mirror. Okay, moved closer to the mirror. Then what is the field of view? Okay, that is the question whatever he asked. For first main, the first question. Now we will see third question. Size of mirror is increased. Then what? If the size of the mirror is increased, then what is the field of view? That means now initial mirror was this much and he increased this much, maybe in some ratio he has increased it. Then what is the field of view he is asking? How it is going to be, he is asking us. Right, so now how are these two questions interlinked, or how are they going to be the same? I will tell you. I'll explain you first. So what first question told? What first question explained is, see, now object initially it was here and it was moved here. Okay, it was moved closer to the mirror, so I can assume it to be here. Okay, now see one thing. Now if from the initial point, if I draw its field of view, maximum possible image possible is this much. Now when this object was moved closer, I could see that larger field of view is possible. Right, so remember the first point and foremost point I would like to say is, when the object is moved closer to the mirror, so obviously the field of view increases. This is the first point I would like to say, because here we have observed it, right? So when it has moved forward, larger field of view is available for us. Clear? Now now when object was far away, what happened? Low field of view. So vice versa, you can just write it. Sorry, now I can't undo this. Sorry. So please adjust with the diagram, because I can't undo this now. Okay. So now if the object is moved far away from the mirror, then field of view is decreases. Okay. So I'm just writing and vice versa. So we need this statement. So that's what we need. Okay. So I said that field of view is going to increase. So we directly we can put the option. Yeah, it is option A. But I'll give you the solution. Don't worry. Just hold on. Now for the third question, I'll explain. If the size of the mirror is increased, then what is the field of view? See, now mirror initially it was this much. Now when it was that much, field of view is this much only. When initial green color wala, okay. So field of view will be this much only. Field of view. Very less. So what happened? When the mirror is increased, when mirror was increased, what happened? The field of view also increased. Because initially mirror was very, then field of view also was very small. So second point what we would like to conclude is, oh just 1 minute, I'll erase. If the mirror size is increased, okay, then what will happen? The field of view will increase. Okay, field of view will increase. Now I will tell you how these questions are interconnected. See what happened in the first case. Here also the field of view increased. Here also the field of view increased. But here object is moved, when object is moved towards the mirror, field of view will increase. When the mirror is increased also, field of view will increase. So both are interconnected in some way, right? That is what you're going to have only same solution for this. Okay. So if you really want the solution for this, I'll just give it. But actually you need not know that solution and all, because again if I give the solution, I have to explain similarity of triangle, then basic proportionality theorem, which is there in your 10th standard. Okay, so again if I give you all that and confuse you, it will be problem for me. So please understand with the diagrams here. Okay, again it will be problematic if I explain all that. So I hope you understood this, right? These two statements, if you want, you note it. This is for the first one. Just write it option A. And then for say third one, also option A. Now second one, we will see, if the distance of the observer has decreased, the field of view will be, obviously it will decrease. So I'll show you the diagram first. So here is the mirror. Here first distance between the observer has decreased. So observer was here, right? He was the observer. Suppose let me take a point as observer. Now what happened? He has what happened? He decreased. That means he came closer to the mirror. Distance between observer and mirror less means that is nothing but he's coming closer to the mirror. Correct. So let me put that closer point somewhere over here. Okay. So suppose he came till here, closer. Now I will draw lines for the initial point. That means rays for the initial point and for the later point. So this is the field of view I am drawing. That means to the last extent, last possible extent. Okay. Now, obviously, you can see that his field of view will decrease. See, it has decreased actually. See, it is decreased compared with the previous one. It is decreased actually. We can observe that very clearly. So when he will move towards the mirror, That means when distance between the observer and the is decreased, when the distance between observer is decreased, distance of the observer is decreased, then field of view also will decrease. Okay, now this is done. Second one is option B. Now see the gold package. Okay, so here we have a plane is placed vertically. I'll draw the diagram and show you. See, now there is a mirror actually. Okay, now that what is that ground distance, what is the distance he gave? 60 meters he has given. Now when a plane mirror is placed horizontally on a level ground at a distance of 60 meters from the foot of the tower. Now let this be the tower. From the foot of the tower, 60 meters on the distance it is placed. Okay, from the foot of the tower, the top of the tower and its image in the mirror subtended 90 degree at the eye. Now this top of the tower is there, no, to the mirror it will subtend at 90 degree. Okay, like this. Okay, so this is the mirror. When mirror is kept means it ulta that image will be showed, right? So he told that this complete angle is 90 degree. What is that? The mirror subtends its angle at 90 degree at the eye. So here is the eye. Okay, now what is the height of the mirror? Sorry, height of the tower. This height we have to find. Okay, this is the sixth question in gold. So how do you find? It's actually using trigonometry, and that trigonometry is going to come to all in 10th standard, but it is there in your Techno syllabus. So you can, I think you can all know. Okay, so first how to find that is, now this entirely it is 90 degree, but we all know that angle of incidence is equal to angle of reflection, right? So both are going to be equal. So that is nothing but equally if you distribute those two angles, this is going to be 45, this is going to be 45. Am I right? Because 90, right? So it is going to be the same, right? So 45, 45, and this is 60, and you have to find this. You know one angle, you know one side, and how to find this? Using trigonometry. What ratio of trigonometry you will use? Tan 45 is equal to opposite side. Let this be h by 60. Tan 45 is 1 is equal to h by 60, and h is equal to 60 meters, which is nothing but option B. So with this we have completed the packages. So I hope you all understood it very clearly, and yeah, it is a lengthy video, even though I hope you understood it clearly. So thanks for watching our video. Do like, share and subscribe to Vishwablooms. Please do support to our channel, and bye bye. See you in the next video.